I'm Jackson. I go to SU. I'm a senior and I'm studying applied math and neuroscience. And today I'm going to be talking about deep learning in image processing and visual effects. And also a shout out to Priscilla because it is her birthday. So everyone say happy birthday to Priscilla, and her putting up with me presenting on her birthday, which she wasn't initially happy about, but it's okay. All right. So just kind of a brief overview of what I'm going to go over. So we're going to talk about machine learning, specific deep learning, which is a subsection of machine learning, and the general term of artificial intelligence. We're going to talk about what currently exists, like what we all have access to as far as those things, like Adobe, Nuke, stuff like that. And then I'm going to talk a little bit more in depth about some of the uses in image processing. So that's going to be stuff like upscaling and other things like that. So just some fun GIFs and stuff associated with it. So let's start talking about machine learning. Machine learning, the best way to describe it is that it's the automation of some optimization or algorithm process. Generally, you're using data to train a model that's going to learn how to optimize itself without any input from a user. So taking a step back, just so everyone's on the same page, an algorithm is a set of followed procedures or steps to produce a result. So like an algorithm to open chips would be, I'm going to open the bag, I'm going to put my hand in, I'm going to pull a chip out, I'm going to put it in my mouth. That would be eating chips, right? So to expand on that, so there's just some problems or like tasks that we want to solve that you can't solve with. My Zoom quit. Oh no.
Hold on. You're still here.
I am still here.
Well, Jackson's Zoom quit.
I mean,
yeah, I've been noticing that lately where it'll say like Zoom has quit and it'll like hang for a while and then it'll come back and then it'll quit again. Fun times.
We can all see your screen still and hear you and see. Until now. Mute.
hi, can you guys hear me?
Yep.
Cool. Okay. Anyway, back to where I was. So traditional algorithms, some examples of them would be like recursive style algorithms. So if you guys are familiar with like if then statements, for loops, while loops, stuff like that, just as simple examples. And also randomized algorithms. So the one that a lot of people will run into is in render engines. Have you ever heard of path tracing? So how some render engines create a rendered image, uses what's called a Monte Carlo technique. So it uses a very large amount of random data, basically throws it at a system and sees what happens. So those are examples of more traditional algorithm approaches in contrast to machine learning. So that, as you can see, with some of those traditional algorithms, they're very set in stone in terms of how they're approached. So some problems just aren't, they require more adaptation. So that's where machine learning comes in. And there's a bunch of different subtypes. I'm not going to get super into the weeds with any of this. There's a lot of subtypes. There's a lot of different types within the subtypes. There's a lot to read about. If any of you guys are interested, I highly recommend. I can give links to stuff if you want. Yeah, so let's move on to deep learning. So the best way to think of deep learning is that it's a subsection of machine learning where you're essentially creating what's called a neural network that I'll get into in the next slide. But it's using a bunch of layers of what are called nodes. The main idea of nodes is that you're modeling the connection between neurons in the human brain. So each node is assigned a weight that corresponds with how best to optimize some output solution. This will be a little bit clearer on the next page. But essentially the weights begin randomly, and then as the model learns, those weights are optimized for what the desired output is. So this neural network that it creates is what distinguishes machine learning and deep learning. Some common ones that you might have heard thrown around are like convolutional neural networks, deep neural networks, et cetera. There's 1,000 different types of them and a bunch of different subsections. But essentially the goal is to simulate kind of neuronal connections and their weights to create an optimized output. And these layers will all transform your data in some specific way. So I think this picture can pretty simply sum up how the distinction between the two. In your more traditional machine learning, you might have a training set that's given by a human. So a person will be like, this is a picture of a dog, this is a picture of a cat, and your algorithm will learn from that information and then output based upon what it thinks is each from that original training set. Whereas in deep learning, the feature extraction and how it's going to classify everything is being done within the nodes, and it's being done starting at random and then working its way down basically. So then moving on to artificial intelligence. In practice right now, most things that you see labeled as AI in software are going to be actually deep learning. AI there's kind of a mixed bag on what people like for the term AI. I'm more of the approach of AI means general AI, which is a conscious kind of human-like being. But that's not necessarily true for what everyone thinks. So this is just my terminology that I'm going to be using here. But a narrow AI, for example, would be a chess bot, right? Something that you kind of think and adapt, but isn't necessarily able to expand beyond what it's originally programmed to do. So in that sense, most of the stuff that I'm going to show you in this that talks about AI is using deep learning. So just to kind of summarize, machine learning is automated algorithm optimization, and a subsection of that is going to be deep learning, which essentially uses a neural network model for that optimization. And then the term AI, for my definition, is basically some showing of intelligence or consciousness. And I hope that it doesn't exist yet. It'd be kind of creepy if it does, but that's a problem for another discussion. So current things that exist. Here's where we start to get into the fun parts. So one of the most common ones that people see is the Adobe's neural filters. Adobe created a huge library of machine learning tools called their Adobe Sensei products. They have applications ranging from marketing to stuff inside of Photoshop. Everything kind of runs through their tools they made for that. But the one I'm going to focus on are the neural filters that you see in things like Photoshop. They have a bunch of different options. Some of them are in beta, some of them are released fully. So that's going to be black and white image colorization, stuff like compression artifact removal, upscaling, skin smoothing, just a lot of tasks that would traditionally could take you quite a bit of time to do yourself, with their end goal being to automate that process rather quickly from a training set. So here's an example of one of their neural filters where you can generate a smile on someone's face. So the example that they give in the middle is them using the liquify tool inside of Photoshop to make the smile. I think they underdid it a little bit just to sell their stuff a little more, but it kind of gets the point across of how it seemed to create a pretty realistic looking smile on him by generating new pixels rather than modifying or manipulating the previous pixels. And then here's an example of their colorization filters. These are super fun to play with, and if it gets it right, the results can be really cool. I had a friend who was taking all of his mom's old photographs and putting them into Photoshop and colorizing them for her for a birthday present. She was like, whoa, this is the coolest thing ever. So there's a lot of cool stuff that's coming out of Adobe's toolbox for that. Does anyone have any questions so far about anything as I blab away? Did I see a hand? I don't know if I saw a hand.
Do you know if Sensei is relying on deep learning?
I think it's a mix.
Yeah.
But I think it does contain deep learning. Yeah. Yeah, because it's such a broad toolbox. I think they kind of just put all of their things, whether it be different types of neural networks, different like machine learning classification or like regression algorithms under the one header.
Yeah.
Yeah. All right. So now we're going to talk about Nuke, specifically their copycat node that they made. This is going to deal more with compositing. So Nuke announced, I think, was it last year? A set of ML tools that users can kind of customize. It's a lot more customizable than Adobe stuff is. So they added upscaling, they added denoising, and they added this copycat node. So the one we're going to focus on is copycat, but they have a bunch of others as well. So the way copycat works is really cool. Basically, it's a very general set of algorithms. So let's say you want to composite someone's head out, right? Create like a garbage mat or something similar. You would roto a couple frames yourself of that video. And then you would basically use those frames that you rotoed yourself as a training model for their deep learning package. And they would then try to do the rest of the task for you on the rest of the frames, with the goal being that it would very much minimize how much work you have to do. So an example that I found of someone using it is they rotoed out their beard. So they wrote out a couple frames. I don't know how well you guys can see this. Can you guys see it okay? Basically, just kind of in action. So he would have rotoed like these first couple frames maybe over here. And then it does the rest. So it's a basic demo of that. And I'm going to play the beginning of this video just to they kind of explain it in their own words of what it can do. Oh no. Can you guys hear, by the way? No?
No.
Make sure I'm sharing. I might not have reshared it with audio. Can you hear it now?
Yeah.
13, you now have access to our new suite of machine learning plugins found in the AIR or Artificial Intelligence Research menu. In this video, we're going to talk about the copycat node. This node replicates custom effects by learning from a set of training images. The key concept here is that you'll feed the node a small number of before and after images, and then the node will do the hard work by learning how to copy the transformation to get from one to the other, saving you a lot of time. Copycat has a neural network inside it. You can think of a neural network as a set of magic numbers or weights that are used to process your input image to produce an output image. But what are these weights? Well, at first, they're just random numbers, which means that your output image will also be random. The aim of Copycat is to train the neural network, that we'll also refer to as our model, to find the perfect weights to make the input images look like the output images that you want. The way we do this is by feeding Copycat pairs of before and after images, or as we call them, input and ground truth images. Collectively, these images are referred to as your dataset. Once your dataset is ready, you can start the iterative process of training. During training, a set of random crops are taken from your input images, processed by the current weights, and the result is compared against your ground truth. Copycat then alters the weight values to try to minimize the difference between the two. This process is called a step, and as the plugin repeats this many times, it learns the best weights to make the input images look like the ground truth images and saves these out in a .cat file.
So yeah, so that's just a brief overview of how it works. I think it's really cool. But yeah, any questions on this stuff so far?
Just because Nuke is, well, you can get a non-commercial license of it for free now, a lot easier than you used to be able to. But there's a little app called EbSynth or EbSynth that can, I think it's some sort of machine learning, but it does a similar thing where you plug in some training frames to it and it basically maps it over some footage. But it's a free like little app. That's I'll drop the link in the chat. Oh, Nuke's not free anymore. You can't get non-commercial anymore. Oh, that sucks.
You can get non-commercial, Nuke. You absolutely, well, you can get non-commercial.
You cannot get it unless you pay.
That's not true. I just got it last week. Non-commercial. It's free.
Yeah, it's still there.
30 days.
It's 100%. So the way it works is that it's a completely renewable license, but you have to re-download. You have to log in once every 30 days to keep it. And you have to re-download it because they update the version every 3 months. So every 3 months, you have to re-download the 2 gigabyte installer file and reinstall it, which is annoying, but free and legal. So I also don't recommend anyone pirate that software because they're the one company that will come after you. And I know people who have had like $10,000 fines and more. So do not pirate that software.
But what if I really wanna?
Get Nuke Indy and pay $500 and feel sad about it.
Fair. Thank you. That is, yep.
But the only advantage you get is 4K output. Everything
Yeah.
else is non-commercial. It has almost, unless you're really into Python or something, you're not missing out on much by just doing non-commercial. The copycat node is very cool. I've never used it. The one thing I know about it is on April Fools, they released a tutorial that showed it creating dragons from scratch, and I believed it for way longer than I should have. But I think it can do other things well, from what I can tell. We don't have it on our pipeline yet, but when it gets there, I'm sure I'll try it out. So it seems cool.
Yeah, thank you guys. It's super cool. I've watched a bunch of videos on it, and I think it'd be really fun to play with. But yeah, so going back, can you guys still see my screen, I assume?
Yeah.
Okay. All right, moving on. So next thing we're gonna talk about Dolly. I think that's how you say it. Not 100% sure. But are any of you guys familiar with this before I talk about it? You guys ever heard of it?
Is that the one that is the art that is completely text generated from scratch? I mean, we're in the
Exactly.
slide now, but yeah, they released a second version of it like last week or something, or it's in beta.
Yeah.
Seems
Yeah.
cool.
Exactly. Yeah. So basically, what you do is you enter text describing what you want it to make, and it'll generate art completely from scratch based upon that text. So it uses a deep learning model, one of the more complicated ones that exists. And like Avery said, they've been actively updating it. It's not currently available to the public yet in its full form, but the goal is to hopefully eventually release it. There's some interesting conversations about it being released as well, because people are concerned about what you might be able to generate with it, given its test results and how good it is in those tests. Just here, if you guys can see this, to show some examples that it generated. So the text that was entered on the left, for example, is a professional high quality illustration of a robot snake. I can't read the rest because my Zoom bar, but I'm sure you can read it. But the art that it makes is really convincing. I think that for what they're trying to get across, it all looks very good. And these are all generated. It's not images that it's pulling from Google, for example. These are all generated by the network. So I think it's super cool. If you go to their website, OpenAI's website, under the research tab, you can actually play with some of the pre-made options that they have. So Priscilla and I were playing with it earlier, and it's really fun. But I'm really curious when this is released to see what people are able to generate, because I think it's pretty game changing in terms of art. Like if you need a very specific thing for a brand, like let's say you want a snake mug, like in the ocean, for example, you wouldn't have to like pay people to make it necessarily. You just enter it and it will generate a bunch of these images, and you could just find one that works for you and move on. So that's one of the leaning a little bit more towards like in between artificial intelligence and deep learning. That's sort of a future outlook product. But yeah, I think it's super cool. And now to talk about some basically image processing applications of deep learning specifically. So first one we're going to talk about is image upscaling. I'm sure a lot of you guys are familiar with this. These tools have been around for a little bit now. But basically the idea of it is that you'd increase an image's resolution after it's been shot, or basically when it's in some form that has a static resolution. So often people will do it beyond what the original sensor is capable of. I think this was originally developed for restoring older videos and photos that were much smaller resolution. But now it's being used for a bunch of different things. So for example, if you have the Resolve Studio, the paid version of Resolve, they have super scale inside of their program, which does this essentially. So here's an example of the image upscaling. On the left, you have the lower resolution image, and on the right is the upscaled image, and just kind of a closer example of it because it's kind of hard to see. You can see how well it predicts. It's basically generating pixels when it does this. So it's not interpolating pixels in the traditional way like a lot of upsampling filters used to do. This one's actually creating its own pixels based on where it thinks there might be detail. So it's a lot of cool stuff that exists with these right now. But it, like I said, it exists in Resolve and Nuke, inside of, I think, Photoshop's neural filters have it as well. So you're starting to see it everywhere. It's going to become a lot more commonplace, I think, especially as they get better. So next one we're going to talk about is low light recovery. This is the one that I'm probably most excited about. these are basically being used to recover underexposed images. Right now, the technology really only exists in research, and is you need to get a large training set from the camera's original sensor. So you can't generalize it to like a camera brand, for example. It has to be a specific manufactured sensor because they're all slightly different. But the images are really impressive that have came out so far. So like here's a sample one where the left image is your underexposed JPEG. It's not raw. You're not able to modify anything. It's already been debayered and everything. And it's able to recover it with essentially no noise on the right, given some training model. So this will be one of the coolest things, I think, for the fix and post statement that you hear a lot, because this is one of those things that might literally make you able to fix almost anything. So yeah, so that's low light recovery. Next one I'm going to skip. If anyone wants to talk about this after I'm finished with all the rest of the slides, I'll talk about it. It gets a little bit more technical than a lot of the other ones, but I think it's pretty cool. So if anyone wants to talk about it after, just let me know. Compression artifact reduction. So as I'm sure a lot of you know, in stuff like JPEG, ProRes, etc., these formats can be prone to sort of like this blocking artifact that you see, especially if your image is heavily compressed, or like if you continuously recompress a JPEG, for example, you're going to start to see some compression artifacts. So people have been using these. I think you see this in Adobe's neural filters now as well, able to actually reduce the artifact that's present. So a sample picture of that would be this, where obviously it says different quality factors. I'm not sure exactly what the quality factors are, but you can see from left to right, all of these images have the JPEG artifact removed, the right being the one that's most representative of what you would see. And the implications for this are pretty cool. This would open the doors to, as our display devices like phones and computers and stuff are able to process more stuff computationally, we're able to reduce bandwidth of streamed media or decrease file sizes, because we can use these machine learning algorithms to essentially recapture data. So like I was saying in this last bullet point, more destructive codecs can be used because you're able to recover more of that data with a neural network. So that's a pretty cool aspect of that as well. And then another one that I'm sure a lot of you are familiar with is denoising and deblurring. Denoising, I think, was one of the first things that people tried to apply machine learning algorithms for, because everything from music production to film and VFX has to deal with noise, aka unwanted signal. So and also deblurring, which is a pretty cool one. So like, let's say you accidentally shoot on too low of a shutter speed when you're doing still photography. Deblurring, stuff like that, is a lot more effective with deep learning algorithms than your more traditional algorithms. So just some examples. This top one's a little bit hard to see exactly what's going on, but this one's been deblurred. The right image is the deblurred one. The left one is more blurry. I like to focus on the woman on the couch's face and the dog. You can kind of see how much the blur has actually been reduced there. I'm not sure how the zoom compression is, but and then next image is an example of denoising. So you have your noisy input image, and then the middle is going to be a traditional method of denoising that you would have seen in like Premiere, After Effects a couple of years ago. And then the one on the far right is using a denoising algorithm. So as you can see, it removes a little bit more of the noise while retaining almost as much detail as the image in the middle. So it outperforms it in that regard. So it's an example of that one. And then just kind of concluding, I kind of flew through these. Wow. So this stuff obviously is still in development, but I think over the next few years, it's going to really change workflows, especially when it comes to stuff like compositing and a lot of things you're going to see camera developer side. So whether it be inside of iPhones and various other like handheld devices or cinema cameras, I think there's going to be a lot of implications for this technology as it gets implemented. This is my opinion. I don't know if it's going to be true, but I would be surprised if I think a lot of compositing artist jobs are going to disappear slowly as this technology gets better, leaving mostly senior level positions that can fix stuff as needed. But it's definitely a field to check out because there's a lot you can do with it. There's so much more than just what I described here. There's applications in everything, like from marketing to just even simple data analysis on sets and stuff like that. Can use predictive models. So yeah, any questions so far? or I guess at the end. Anything you guys want to talk about?
What's debayering?
Yeah, so I can talk about that one slide if we want to. All right, just walk because I got some time. So let's go back to this. So debayering is the process. Basically, when your camera captures light on its sensor, there's a filter pattern on top of the sensor, and that's how you capture your different colors you're going to actually have in your image. But it doesn't just look like your standard RGB image when it's being captured. The filter actually is kind of this grid-like pattern that appears. So I think a good example of that grid-like pattern is the bottom left corner in the original Bear image. So you can see it has these small subsections of red, green, and blue pixels, and they all are different ratios of how many there are and stuff like that. But traditionally, you have to essentially interpolate between your points of the colors to generate what your actual output color will be. So in this top figure in the middle where it says RGB image after demosaicing, which demosaicing is the same thing as debayering, this is what your output image looks like because it tends to favor green weights. And then you have to do additional image processing operations to actually get a clean RGB image where you then introduce a color space and things like that. So what people have been doing is they've been using experimenting with neural networks to actually do this debayering process rather than your traditional interpolation for the demosaicing and operations you have to do after to retain original color, which not only reduces the number of steps you have to go at, but they found that the interpolation process can actually be more accurate using machine learning algorithms. So like, for example, if there's, it's probably pretty hard to see on Zoom, but your typical OpenCV interpolation is shown here of this debayed image. If you can see my mouse cursor, I don't know if you can. And then the one on the far right is a deep neural network training model. And the debayed image actually looks pretty, it looks a little bit sharper to me. From what I can see, I'm not sure how much you guys can see it. It's just a little bit different. Then I'm not sure what this manual filter is. This person might have manually debayed it, but yeah, so that's one of the applications inside of debayering. The end goal might be able to marginally increase the sharpness, perceived sharpness of your input image, because at the end of the day, your camera's image is being interpolated from the beginning. Interpolated meaning you're essentially trying to guess at values in between two specific values, right? And in that process, you might miss something. You might create certain artifacts. So that's where this would hopefully step in and make the process a lot more streamlined and less full of artifacts.
So I noticed that, GPU processing for deep learning and machine learning is kind of standards. That what's the reason for that GPU models are favored over CPU, or are they?
So yeah, so from my understanding, the reason that you're going to want to use GPUs is because GPUs are largely matrix calculators is the easiest way to think of them. So they work best with large data sets.
Gotcha.
So that's why they're really good for image processing, because your image is essentially a giant matrix, right?
Mm-hmm.
Yeah, so that's why people favor it for machine learning, because you have such large data sets you're working with in your training model.
Excellent.
Any other questions?
They're easily paralleled too if you can afford them.
Yeah, you can find one.
Yeah, exactly. Soon, this summer, I think, maybe.
Hopefully, yeah. Avoid the scalpers.
Yeah.
Yeah. Any other questions? Anything you guys want me to talk about when it comes to deep learning, machine learning? I can try my best.
So what's next? So for the people who do this work right now, what should they be looking into to get into the next big thing?
So I think at a baseline, just familiarity with these tools would be really useful. So learning how they, just at a base level, like what we talked about, or even a little bit more beyond that, like pulling some APIs and looking at what they actually do. Just learning how they work and which ones might best suit specific situations. Having knowledge of this stuff will never hurt you, because at the end of the day, the people who make this stuff might be the last people in a job in the far distant future. So we'll see where everything goes, but I would tentatively say at least have a familiarity with the technology if you're going to be going into any VFX or post-production field, because it's going to show up where you work eventually. Because like they're just so useful in so many different applications. A good example is I work in a lab that does cardiology research, and I would have never thought that we were using models like this for what we're doing. And we've started using deep learning models to predict certain seizure events. I can't go too in depth on what we're doing with it, but certain variables we thought were important are actually not, by using deep learning, because we're not classifying the variables based upon their perceived use. So like, for example, in this situation, we would normally be describing what variables are important, what are not. And these models have shown us that what we originally thought was important might not be. So applications like that are going to be everywhere in marketing and business and VFX everywhere. So I would definitely have a familiarity with the concept.
I was going to bring that up when you were on the slide originally, the difference between machine and deep learning, that deep learning seems to remove a potential input of human bias in the process too.
Exactly.
So yeah, interesting.
Yeah. So a lot of deep learning models are used for exploratory research. So when you're trying to look for some trend or some connection between variables that we just haven't noticed, a lot of times they're able to pick up on stuff like, for example, just the example I was just talking about, like certain variables we thought were important are actually not, because they're already embedded in our data. So we can focus on other variables then, and that gives us more information than we would have had before. I think is there a question in the chat? Yeah. Ooh, thoughts on deepfakes in their open source format. So I have a slightly edgier, I think, opinion of this, but I would prefer everything be open source if possible. I like transparency, especially when it comes to technology. I think the outcome of deepfakes has been less than ideal. But I think that the technology, I'm very much someone who supports the continued development of technology, and I would prefer it in an open format. So ideally, I'd like, for example, journals to all be open source. We don't have a paywall behind them, so people can learn about, for example, this, where are you? Dolly uses a GPT-3 model. It's a language processing model for machine learning. Almost every piece of information you're going to find about it that's technical, if you wanted to use it yourself, is going to be behind a paywall of a journal. So, yeah. You can use stuff to get around it, but at the end of the day, I think that information should be publicly available. All it does is hinder progress, especially because a lot of people can do this stuff at home now. But yeah, so stuff like that would be really useful. But yeah, those are my thoughts on deepfakes. I'm not a fan of their potential uses, but I do want everything to be open source if possible. I'm also very supportive of technology that's trying to discover what is a deepfake and what isn't a deepfake. I think at SU there's actually a research group that's doing that right now. So they're trying to distinguish both real and fake news and real and fake like videos or photos based upon certain aspects of the compression, blah, 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 stuff like that. So any other questions? Thoughts? What do you guys think of machine learning and deep learning and AI? Does it scare you at all? Where a lot of this is headed?
Nah, bring on the robots. We can take them.
Anyone worried they might lose their job over it eventually?
Everyone should.
It gives me a timeline to rise above my incompetency within the next 10 years. So that way I don't get replaced. If I don't have a nice desk by then, it means I just won't have a job.
Exactly. That's good. Yeah. I mean, that's all I have. If anyone wants me to go in depth, talk about anything else, just let me know. But yeah, kind of a short sup for you guys today.
Well, I was going to bring that up when you're talking about needing to kind of familiarize yourself with these tools, especially in the next 10 years that, a number of artist positions become consolidated or disappear entirely. They are essentially tools, and there is a human that has to ultimately, discern, what looks decent and what doesn't, even though a lot of it becomes automated. So, to think of like creative just disappearing and being ceded to like AI, I can't, until there's something like a general AI, I can't like perceive that being possible. But once there's general AI, then you wouldn't need any part of the vertical structure, like All decision
Yeah.
making to up through the C-suite could be totally automated.
At that
Yeah.
point, we have much bigger concerns than visual effects jobs once they're able to replace us on that level. So I always think of in the Charlie and the Chocolate Factory movie, the dad, he loses his job at the toothpaste factory, screwing caps on toothpastes. But at the end of the movie, he gets a job repairing the machines that replaced him. So no matter what, there's a spot for people and there's always jobs.
Yeah.
But it's just going to be kind of not the same landscape. It's probably how people feel that worked with like optical printers and like emulsion processes about what we do, where it's like, it's not the same. It's not the same sexy environment. It's like, yeah, but it's better and it's easier. And that means it's more accessible and more people get to do it. So I don't know. It's all good. Progress is good.
Yeah, I think it's similar to the whole like once consumer cameras became better and better, people were like, oh, if photography as a job is going to disappear. And while certainly there was a reduction in jobs, it's not disappearing anytime soon because there's a craft element to it and there's a lot of other factors. So
But that eventually led to TikTok, which is just sad. So
that's just a glimpse into our future as a species is TikTok.
Exactly. Yeah.
I'm still ready to give my SUP presentation on becoming a TikTok influencer. I think it'll draw the masses.